Do DC adapters consume energy when no device is drawing DC current? Do DC adapters consume energy when no device is drawing DC current? Or, can I leave my mobile, 5 to 20 W, or laptop, 40 to 60 and NBSP, W, chargers plugged in and switched on and hope they won't draw current if my mobile or laptop isn't plugged into the charger? The confusion arises because if we were only considering pure DC or pure AC, then we know that as long as circuit isn't complete, no power is consumed. But when there's an AC to DC adapter, I don't know what's going on in that box. Maybe the converter is consuming power even though nothing is plugged in.
All of the answers here have been useful in part to answer my question, so I'm creating a community wiki answer. Please scroll and upvote them. It will depend on the quality of your adapter. So unless you're sure, better turn it off. Mario's answer gives us a way of testing how your adapter behaves, using which John's answer reported how 2 laptop adapters behave, which can be indicative of other brand adapters as well. Another way to find an upper limit for power drawn while nothing is plugged in is to see if your adapter conforms to some standards. User 2813274's answer contains some information about one of these standards, US Energy Star Spec. BinaryOps20's answer details the reasons an adapter may draw power even when no device is plugged in.
This really depends on the inner workings of the individual adapter. A cheap one might just continue running, while a more elaborate one will turn itself, almost completely, off. For example, Nintendo's power adapters for the Wii U and 3DS are basically dormant when not connected. The current is simply too low for measurement, at least in my case. If you're curious, you can buy an energy meter, which is like a plug you put between the outlet and the device you want to measure. It will tell you the current amount of power consumed as well as the consumption over time.
All power adapters have some parasitic loss inside them, such as switching loss from hysteresis of the transformer, switching loss from transistors, leakage current, partial conduction from moves /X/Y caps, age/wear. However, like Mario has advised, they do ramp up/down subject to demand, but only for smart chargers like your laptop and not so much for basic devices such as wall warts.
I hooked up a Lenovo 65-watt adapter to a good watt meter and it drew less than 1 watt after the first surge of plugging in, 2 watts. I tried an Apple adapter and it did not even register. Ordinary good quality adapters do not draw appreciable current and can be left plugged in without any concern. I trust this helps.